I want you to picture something for a second. Think of a classic mid-20th century American illustration, like an old comic strip or maybe a Norman Rockwell painting.
Oh, sure.
Yeah, the image is instantly recognizable, right? It's a child sitting up in bed, looking just completely, thoroughly miserable.
With the giant bandage.
Exactly. They have this giant cloth bandage wrapped completely around their jaw, and it's tied in this neat little knot right at the top of their head.
Right, like a cartoon character with a toothache.
Right. And their cheeks are swollen outward, puffed up like like a chipmunk storing acorns. For decades, that very specific image was the universally understood visual shorthand for a child being homesick.
It really was a massive cultural staple. I mean, the swollen jaw is the clinical hallmark of viral parotitis.
Which is the inflammation of the parotid salivary glands.
Exactly. And because the infection was just so ubiquitous before the vaccine era, the imagery surrounding it became, well, heavily stylized. It was almost endearing in a weird way.
Yeah, and you are picturing mumps, obviously. And for generations, mumps was treated by the general public as, honestly, kind of a punchline.
It totally was.
It was viewed as this universal, slightly annoying rite of passage that literally every child was simply expected to endure, right alongside losing baby teeth or scraping a knee.
Just a normal part of growing up.
Right. But we are looking at this disease today on this deep dive through the lens of a public health doctor analyzing some of the most complex and honestly surprising vaccine trends of the modern era.
And it is a fascinating topic to unpack.
It really is, because when you strip away the vintage cartoons, mumps reveals itself as a disease of profound contradictions. I mean, it provides American medicine with its most intimately human origin story, while simultaneously delivering one of its most humbling modern lessons.
That's a great way to frame it. Because the historical narrative we all sort of cling to regarding disease eradication is largely triumphalist, you know.
What do you mean by triumphal?
Well, the societal assumption is that scientists invent a vaccine, the germ is eradicated, we close the textbook, and humanity just moves forward. Like a closed case.
Like polio or smallpox.
Exactly. But mumps dismantling that narrative is what makes the epidemiological data we have today so compelling. It proves that public health is, well, it's never a finished victory. It is a state of perpetual active monitoring.
And we are going to trace that biological and historical timeline chronologically for you today. We will look at the terrifying clinical reality of mumps before the vaccine, followed by this incredible midnight throat swab in 1963 that completely altered medical history.
A truly wild story.
Yeah, and then we will look at the massive modern-day outbreaks on college campuses that basically forced immunologists to completely rethink the mechanics of viral protection.
So to really understand the stakes here, I think we have to look at what the mumps virus actually is.
Let's do it.
It is an ancient pathogen. It's a paramyxovirus.
Yeah.
And it was actually first detailed clinically by Hippocrates in ancient Greece.
Wow, Hippocrates. So this thing's been with us for a long time.
A very long time. And prior to the widespread availability of the vaccine, it was a near universal childhood illness here in the United States. Basically, everyone got it.
But the comedic reputation it held in popular culture completely masked its danger, right? Like, if you were a pediatrician in the 1940s or 1950s, you weren't looking at funny chipmunk cheeks.
No, absolutely not.
You were dealing with the neurological and systemic fallout of a highly invasive virus. So let's look at the actual clinical profile. Because before the vaccine, mumps was the leading cause of acquired deafness in American children.
Which is just a devastating statistic when you consider the sheer volume of infections we're talking about.
Right.
And we should distinguish here from congenital deafness, where a child is born without hearing. This was acquired sensorineural hearing loss.
Meaning they had normal hearing, caught a virus, and lost it.
Exactly. A child would contract this really common respiratory virus, develop the fever and the swollen salivary glands, and then the virus would migrate.
Because it doesn't just stay in the jaw.
Right. It has a specific tropism, which is basically an affinity for the central nervous system and the inner ear structures.
So it's actively seeking out those areas.
Yeah, it would trigger something called endolymphatic labyrinthitis, which effectively destroys the hair cells in the cochlea, or it can even damage the auditory nerve itself.
And it was often unilateral, right? Meaning it affected just one ear.
Yes, very often unilateral. It would strike suddenly, and the child would just permanently lose a hearing in one ear.
That's terrifying. A parent puts their child to bed with a fever and a swollen jaw, and the child wakes up with irreversible hearing loss.
And the damage didn't stop at the auditory nerve either, because mumps is a systemic virus. It readily crosses the blood-brain barrier.
Which is something a simple cold virus generally does not do.
Exactly. So it was actually a leading cause of aseptic meningitis.
Break that down for us. What is aseptic meningitis in this context?
Sure, so that's the viral inflammation of the meninges, which are the protective membranes encasing the brain and spinal cord.
Oh.
Yeah. In a clinical setting, this presents with intense nuchal rigidity, or basically severe neck stiffness, and severe photophobia, which means light hurts your eyes, and extreme lethargy.
Just a miserable experience for a kid.
And in more severe cases, it progressed from meningitis to encephalitis, meaning the virus was directly infecting and inflaming the brain parenchyma, the actual functional tissue of the brain itself.
Oh, wow. So you're dealing with swelling directly inside the brain.
Right. You would see children presenting with seizures, altered mental states, and facing the very real risk of lasting neurological deficits.
Okay, so that's the pediatric side of things. But then there was a completely different demographic threat that I think we need to talk about.
The adult males.
Exactly. For adolescents and adult men who somehow managed to, avoid catching the virus in childhood, contracting mumps later in life carried a specific, deeply feared complication.
Orchitis.
Yes, orchitis.
Which is the acute, severe inflammation of the testicles.
Right. And the pathophysiology here is fascinating, but honestly brutal.
It really is. So the mumps virus enters through the respiratory tract, right? It replicates in the local lymph nodes, and then it spills into the bloodstream.
That phase is called viremia, right?
Yes, viremia.
Yeah.
And because the virus has that strong affinity for glandular epithelial cells, it uses the bloodstream to travel down to the testes. It crosses the endothelial barrier and infects the actual testicular tissue.
So the intense pain that these men were experiencing isn't just from the virus itself. It's actually a mechanical issue caused by the body's own anatomy.
Exactly. The testes are encased in this tough, fibrous, inelastic capsule called the tunica albuginea.
Inelastic being the key word there. It doesn't stretch.
Right. It doesn't stretch at all. So when the mumps virus triggers massive inflammation and swelling within that rigid capsule, the tissue literally has nowhere to expand.
Yikes.
The internal pressure just skyrockets. And this can lead to ischemia, which is a restriction of blood supply to the tissues.
Which has to be excruciatingly painful.
Beyond painful. And the long-term consequence of that ischemic damage is testicular atrophy. And in severe bilateral cases, meaning it affects both sides, permanent sterility.
Wow.
Now, there is a female equivalent, euphoritis, involving the ovaries, but the risk of permanent fertility issues was historically recognized as a massive, looming threat primarily for adult men.
Okay, let's unpack this for a second, because the cognitive dissonance here is just striking to me.
How so?
Well, if mumps was actively causing sudden deafness in children, swelling of the brain, and potential sterility in adult men, why did society collectively decide to paint it as a funny, mild milestone with cartoon head bandages? Like, how does that happen?
It's a great question, and it really points to a necessary sociological coping mechanism.
Coping mechanism?
Yeah, think about it. When a pathogen is highly contagious and totally unavoidable, when you are dealing with a near 100% infection rate across the population over time, society is basically forced to normalize it.
Because everyone is going to get it eventually.
Right. If parents lived in a state of acute terror regarding an event statistically guaranteed to happen to their child, the collective anxiety would be completely paralyzing.
Oh, I see. So you have to make a joke out of it to survive the reality of it.
Exactly. The culture softens the narrative. We focus on the puffy cheeks and treat it as a shared nuisance. But for the medical professionals, the ones actually treating a newly deaf 6-year-old or managing the agonizing complications of orchitis, the normalization was a total illusion.
It was an urgent public health crisis.
Yes, just waiting for a biological intervention.
And that biological intervention began on a specific night in March of 1963, which created what is arguably the most intimately human origin story in all of vaccinology.
It really is a beautiful story.
We are looking at the home of Dr. Maurice Hilleman. He was a scientist at Merck. And Hilleman is widely regarded as one of the most prolific vaccine developers in history. But on this particular night, he wasn't in a high-tech lab. He was dealing with a sick 5-year-old daughter.
Right, his daughter, Jeryl Lynn. She woke up in the middle of the night with a fever, crying, and she was presenting with the unmistakable unilateral swelling of the parotid gland.
So she had mumps.
She had mumps. Now, the standard protocol for a parent in 1963 was just palliative care.
Which means what, exactly?
Providing aspirin, a cool cloth for her forehead, and just waiting for the immune system to clear the infection. There was nothing else to do.
But Hilleman viewed the situation a little differently.
Very differently.
He recognized the immediate window of opportunity to isolate the wild virus while it was actively replicating right there in his daughter's upper respiratory tract.
Which is such a scientist thing to do.
Right. Instead of just giving her a glass of water and going back to sleep, he drove from his home to his laboratory at Merck, retrieved sterile culture media and swabs, drove all the way back, and swabbed the back of Jeryl Lynn's throat.
He captured the wild pathogenic virus directly from his own child.
Yeah. It's like a mechanic fixing a family car, but on a microscopic, world-changing scale. It's literally the warmest origin story in public health, you know. The cure came directly from a child's sore throat.
It's incredible. And he then took that swab and returned to the lab to culture the sample.
Okay, explain culturing for us.
Culturing requires coaxing the virus to survive and replicate outside the human body. He inoculated the swab material into chick embryo tissue cultures.
Chick embryos. Why chicken cells?
That was the critical first step in what would become a master class in viral attenuation. To make a vaccine, you have to grow the virus, but you have to weaken it.
Right. Let's look at the mechanics of that attenuation, because he needed to turn a very dangerous pathogen into a safe vaccine. How exactly do you force a virus to, forget how to cause disease in humans?
Through a fascinating process called serial passage.
Serial passage. Okay, how does that work?
So Hilleman took the mumps virus, isolated from Jeryl Lynn, and he introduced it to a layer of embryonated chicken cells in a petri dish. Now, human mumps virus doesn't naturally thrive in avian cells.
Because it's a human virus.
Right. It is an alien environment for the virus. So most of the viral particles just die. But viruses mutate rapidly, and a tiny fraction of the viral population possessed random genetic variations that allowed them to infect the chicken cells and replicate.
So he is artificially applying evolutionary pressure.
He is. It's guided evolution. He then took the surviving, successfully replicating virus from that first dish and introduced it to a fresh batch of chicken cells.
A second passage.
Yes. And he repeated this process, passaging the virus generation after generation. With each passage, the virus became better and better adapted to growing in chicken tissue.
Okay, but how does that make it safe for humans?
Because biology demands trade-offs. As the virus evolved to become a complete master at infecting avian cells, it simultaneously lost its genetic ability to effectively infect and cause severe disease in human cells.
Oh, wow. It basically specialized so much in chickens that it forgot how to be a human pathogen.
Exactly. It became attenuated or weakened.
But it still looks the same to our bodies.
Yes. The virus still looks identical to the human immune system on a structural level, so when it's injected, it provokes a robust antibody response. But it completely lacks the genetic machinery to trigger the parotitis, the meningitis, or the deafness.
That is brilliant. And the timeline of this development was just remarkably compressed. I mean, from the night Hilleman swabbed his daughter's throat in 1963 to the moment the attenuated vaccine was licensed by the federal government, only 4 years had passed.
4 years is lightning speed in vaccine development.
Right. It was rolled out in 1967 and officially named the Jeryl Lynn strain after his daughter.
And what's really fascinating here is the legacy of that specific isolation. It's unparalleled.
What do you mean?
The exact genetic lineage of the virus cultured from Jeryl Lynn's throat in 1963 remains the sole mumps component used in vaccines globally today.
Wait, really? The exact same strain?
The exact same strain.
Yeah.
Anyone immunized against mumps today carries immunological protection generated by a direct weakened descendant of the virus that caused a 5-year-old girl's fever over 60 years ago.
That gives me chills. That is amazing. And the introduction of the Jeryl Lynn strain really ushered in what felt like the absolute end of the disease in America.
It certainly felt that way.
In 1971, Hilleman combined his mumps vaccine with the vaccines for measles and rubella, creating the trivalent MMR shot.
Which was a huge logistical breakthrough. It allowed pediatricians to confer broad protection against 3 major diseases without requiring multiple separate injections for kids.
And the public health data following the rollout of the MMR was just staggering. We saw routine one-dose recommendations implemented for all children in 1977.
Right, and as epidemiologists gathered more data, particularly on measles transmission dynamics, they actually updated the schedule in 1989 to a 2-dose recommendation.
Which is an initial shot for toddlers and a booster prior to entering the school system.
Exactly. And the result of that 2-dose schedule was a 99% reduction in mumps cases compared to the pre-vaccine era.
99%. That is incredible. A disease that was once an unavoidable fact of childhood was functionally erased from the clinical landscape.
Truly erased. You had a whole generation of young physicians graduating from medical school having never observed a live case of mumps.
So what does this all mean for public health at the time? Did doctors just assume mumps was a closed chapter like smallpox or rubella?
Yeah, they really did.
Yeah.
This massive success birthed that psychological trap of triumphalism within the public health establishment that we talked about earlier.
Because the measles and rubella parts of the shot were doing so well.
Exactly. The other two components of the MMR shot, measles and rubella, were aggressively pushed toward elimination in the United States. Measles requires an incredibly high herd immunity threshold, but the two doses were achieving it.
Okay, so because the M and the R were vanishing.
The medical consensus simply assumed the first mumps was an equally permanent closed chapter. They literally stopped anticipating the disease. They didn't think they'd see it again.
But unlike measles, mumps was quietly setting a trap.
It absolutely was.
And the alarm bells wouldn't ring in elementary schools where the vaccine was administered. They rang in college dorms decades later.
The uncomfortable sequel.
Right. Fast forward to 2006. The medical community was completely blindsided by a massive, explosive mumps outbreak across the American Midwest, totaling roughly 6,500 cases.
And it wasn't a fluke. A decade later, in 2016 and 2017, even larger outbreaks surged through the country.
And here's the most shocking detail. The demographic data from these outbreaks generated immense concern among epidemiologists because these clusters were not emerging in pockets of the unvaccinated population.
No, they weren't.
And they weren't among communities with, philosophical exemptions. The outbreaks were heavily concentrated among young adults, specifically college students, who possessed documented proof of receiving both recommended doses of the MMR vaccine during childhood.
Which is the crux of the modern mumps problem.
Here's where it gets really interesting. If these students did everything right and got their 2 doses, why on earth were they getting sick? As a public health doctor, how do you not panic and assume the vaccine is fundamentally broken?
Well, the initial fear certainly was either primary vaccine failure or a radical mutation of the wild virus. I mean, investigators rushed in to study the virus in the patients.
So what did they look at first?
To determine the cause, they had to analyze the specific environment, acting as a catalyst for these outbreaks. The modern college dorm.
Why the dorm?
Because a university dormitory is a highly unique epidemiological environment. You have thousands of young adults living in extreme constant proximity.
Right.
They share sleeping quarters, bathrooms, utensils, and engage in high-contact social activities.
It is the ultimate pressure cooker for a respiratory virus. The sheer volume of viral particles being exchanged in a dorm room or at a crowded campus party is exponentially higher than what a person encounters walking through a grocery store.
Absolutely. The viral inoculum, which is the actual dose of the virus a person is exposed to, is just massive in those settings.
Okay, but a high viral load alone shouldn't breach a fully immunized system if the immunity is robust.
Exactly. So investigators cultured the virus from the infected college students and mapped its genome. They needed to know if the wild virus had mutated its surface proteins to evade the antibodies generated by the 1963 Jeryl Lynn strain.
They needed to know if the virus picked the lock.
Yes. Did the virus mutate to escape?
And did it?
It did not. The sequencing revealed no significant antigenic drift. The virus causing the outbreaks in 2006 and 2016 was effectively the exact same virus the vaccine was designed to stop.
Oh.
So the vaccine hadn't failed to confer immunity initially, and the virus hadn't mutated to escape it. The science pointed definitively to a distinct biological phenomenon, waning immunity.
Okay, we need to carefully dissect the mechanics of waning immunity here because the public often conflates it with vaccine failure.
They do, all the time.
Protection against mumps, unlike measles, simply fades over the years after vaccination. I like to think of it like a flashlight battery.
Oh, that's a good analogy.
Yeah, it's not that the flashlight is broken or that the darkness got stronger. The battery just naturally lost its charge over 15 years, and suddenly you're in a crowded dorm where you really need that light, and it's dim.
That is perfectly stated. And to understand why that happens, we have to look at how the immune system processes different viral antigens and the types of memory cells it generates.
So why does immunity to mumps fade over time when immunity to measles, administered in the exact same syringe, generally lasts a lifetime?
It comes down to the types of cells created. When you receive the measles vaccine, The antigens stimulate the immune system to create a massive population of long-lived plasma cells.
Plasma cells, okay.
These plasma cells migrate to the bone marrow and act like a standing army. They continuously, constantly pump out high levels of neutralizing antibodies into the bloodstream for decades.
So they are always on duty.
Always on duty. If you're exposed to measles 20 years later, those antibodies are already there. They neutralize the virus instantly before it can even establish an infection.
But the mumps component of the MMR behaves differently.
Yes, the Jeryl Lynn strain is highly effective at halting the disease in childhood, but it appears to be less efficient at generating those permanent, long-lived plasma cells.
So what does it leave behind instead?
Instead, the mumps vaccine primarily leaves behind memory B cells, and memory B cells are more like military reservists.
Reservists,
Yeah.
not the standing army.
Right. They don't actively pump out antibodies all the time. They just patrol the lymphatic system quietly, waiting to recognize the mumps virus if it ever shows up again.
So let's play this out. When a vaccinated 20-year-old walks into a crowded dorm room where someone is actively shedding the mumps virus, what happens at the cellular level?
The virus enters the respiratory tract and begins replicating. Now, the memory B cells eventually recognize the virus, but because they're reservists, they need time to gear up.
They aren't ready to fight on day one.
Exactly. They have to undergo a process called clonal expansion, which means multiplying rapidly, and then they have to differentiate into active plasma cells before they can produce the antibodies needed to clear the infection.
And in a college dorm, the initial dose of the virus is so high that the pathogen simply outpaces the reservists.
Exactly. The virus establishes a clinical infection, causing the swollen parotid glands and the fever before the memory B cells can mount a sufficient counterattack.
But the immunity hasn't disappeared completely, right?
No, not completely, which is why severe complications like deafness and orchitis are far rarer in vaccinated outbreak patients than they were in the pre-vaccine era.
Okay, that makes sense. The immune system is slow, but it still eventually fights it off before the severe stuff happens.
Right, but the defensive wall has thinned out enough over 15 years to allow the primary illness to take hold.
This distinction is so crucial for maintaining public confidence in the vaccination program. Because if we connect this to the bigger picture, it is crucial to distinguish between vaccine failure, immune escape, and waning immunity.
Absolutely. Primary vaccine failure means the shot literally never worked in the first place. Immune escape means the virus morphed into something unrecognizable.
And waning immunity means the initial protection was flawless, the virus remains unchanged, but the concentration of circulating antibodies has naturally decayed over time.
Exactly. And mumps is strictly an issue of waning immunity.
So once public health doctors understood that the issue was time, not mutation, they had to figure out how to stop the campus outbreaks without overreacting.
Right, because once the CDC and public health doctors isolated waning immunity as the sole culprit, they faced a very difficult policy question. How do you halt these explosive outbreaks without inciting a massive panic or overhauling the entire national pediatric vaccine schedule?
Well, the logical answer to waning immunity is to provide the immune system with a reminder, right?
Okay.
A booster.
Yes.
So in 2017 and 2018, the CDC's Advisory Committee on Immunization Practices, the ACIP, reviewed the outbreak data and formulated a highly specific response.
The targeted third dose.
A targeted third dose. Detail that recommendation for us.
The ACIP officially recommended a third dose of the MMR vaccine, but they restricted their recommendations specifically to individuals identified by public health authorities as being at increased risk during an active mumps outbreak.
Wait, if the biological reality is that mumps immunity wanes for everyone over the course of 15 years, why wouldn't the ACIP just mandate a universal third dose campaign for every single young adult in America? Why limit it only to specific groups during an active outbreak?
It's a great question, and it's exactly what epidemiologists had to model.
And furthermore, if the second dose waned, won't the third dose eventually wane too? What does a third shot actually achieve biologically that the second one didn't?
Okay, let's address the first point. Why not everyone? Because risk in public health is a combination of biological susceptibility and environmental exposure.
Susceptibility and exposure, okay.
Right. While a 25-year-old software developer working from home has diminished mumps immunity, their environmental risk of actually encountering a high viral load of mumps is virtually zero.
Because they aren't living in a dorm.
Exactly. And a universal third dose campaign requires immense logistical resources and financial cost to prevent a disease that is no longer endemic in the general population.
So the risk is highly situational. It requires the waning immunity to collide with the high-density environment of a dorm room or, like, a military barracks.
Precisely. As for the biology of the third dose, you were correct. A third dose does not confer permanent lifelong immunity either. The antibody titers will eventually decline again,
So why do it?
because the third dose serves as a tactical strike. When you administer a third MMR shot to a college student during an outbreak, you immediately force those memory B-cell reservists into active duty.
Oh.
The body produces a massive, rapid spike in circulating neutralizing antibodies.
You temporarily rebuild the standing army.
Yes, you rebuild the army right when the enemy is at the gates. That massive spike in antibodies provides a temporary but incredibly robust shield. If a local health department identifies an outbreak in a specific dormitory, vaccinating those specific residents with a third dose creates a sudden, localized surge in herd immunity.
It basically starves the virus of susceptible hosts.
Exactly. It breaks the chain of transmission and suffocates the outbreak. It is an intervention designed to control a localized crisis, not to alter the lifelong immune profile of the entire country.
That dynamic illustrates a really fascinating contrast in the history of this vaccine. Because on one hand, you have the initial creation of the Jeryl Lynn strain, which is this story of individual scientific brilliance, right?
Maurice Hilleman in the middle of the night.
Right. A lone researcher at Merck cultures a virus from his daughter's throat and single-handedly develops a cure. It happens almost entirely outside the purview of the government.
But the maintenance of that scientific miracle is entirely dependent on public infrastructure. The Jeryl Lynn strain is a brilliant tool, but a tool requires an operator.
Exactly. The ongoing surveillance, the genomic sequencing of the virus in 2006 to rule out mutation, the tracking of the epidemiological clusters in the Midwest, and the nuanced, data-driven deployment of the third dose. That is, the invisible structural work of federal public health.
The government did not invent the mumps vaccine, but the government is the entity actively monitoring the epidemiological horizon.
Right.
When the protective wall built in the 1960s began to thin out 20 years later, it was the CDC and the ACIP that identified the structural weakness and coordinated the response to patch it.
Which really brings us to the grand thesis of this deep dive. What does the complicated history of mumps actually teach us about the fundamental nature of disease prevention?
It dismantles the myth of permanent eradication for many pathogens. We love to celebrate the absolute victories, the eradication of smallpox, the near elimination of polio, and those triumphs leave the public with the false impression that vaccination is a closed book, a permanent victory.
We assume biology is a machine that can be programmed once and then just forgotten.
But mumps proves that immunity has a half-life. The body forgets, the antibodies degrade, the memory cells go dormant, and the pathogen, which has been quietly circulating at low levels, just waits for the right high-density environment to exploit the gap.
It means public health is never finished, only maintained. It's unglamorous, it requires endless watchfulness, and it forces us to be humble in the face of biology.
It requires surveillance networks that never shut down and policy committees that constantly adjust their strategies based on real-time cellular data. This ongoing maintenance is exactly what the public health system exists to do, and it is the kind of invisible infrastructure society relies on, whether they realize it or not.
We have covered an immense amount of ground today. We started by looking at the stark reality of pre-vaccine mumps, moving past the vintage cartoons of swollen cheeks to understand the mechanisms of acquired childhood deafness, aseptic meningitis, and the severe threat of adult orchitis.
We examined the midnight swab of Jeryl Lynn Hilleman in 1963, exploring how Maurice Hilleman used serial passage to force the evolutionary attenuation of a dangerous pathogen.
Creating a vaccine strain that remains the global standard over half a century later?
And we traced the triumphalism of the MMR era, where a 99% drop in cases led doctors to believe mumps was permanently conquered.
Only to be shocked by the humbling college campus outbreaks of 2006 and 2016.
We explored the cellular biology behind those outbreaks, distinguishing between vaccine failure, viral mutation, and the reality of waning immunity.
Where that gradual shift from circulating antibodies to dormant memory B cells leaves young adults vulnerable in high-exposure environments like dorms.
And finally, we saw how the targeted use of a third dose acts as a tactical public health intervention to rapidly break the chain of transmission.
It is a profound story of medical miracles requiring endless public maintenance. As we wrap up this deep dive into the source material, I want to leave you with a final thought to ponder.
I love these. Let's hear it.
If a miracle vaccine derived from one child's throat in 1963 can nearly erase a disease, yet still require our active federal surveillance and targeted third doses decades later simply because our own biology forgets how to fight it, What other seemingly conquered diseases from our historical past are just waiting quietly in the wings, biding their time until our collective immunity battery inevitably grains?
Hmm. That is a chilling but necessary thought.
Thank you for joining us on this deep dive.